The whole
economics.
point is that even though there's a good aspect to all these software programs, the downside is that you can fabricate truth because it cannot tell the difference between false.
The synergy between artificial intelligence and quantum computing is growing at an exponential rate, and for most scientists, this is good news. However, for experts like Michio Kaku, this eerie interaction could lead to deadly consequences, including the potential destruction of our civilization. But what exactly does Michio Kaku have against this unprecedented combination? And why did the US government ask NASA and Google to halt their advances into AI and quantum computing? Let's find out. Quantum computing is a study area of computer science that stems from quantum theory, a concept that explains the behavior of matter and energy on the atomic and subatomic level. The term quantum computing was first introduced in the 1980s as scientists sought intuitive ways to tackle computational problems using quantum algorithms. This efficient model has the capability to scour through large numbers of possibilities to come up with solutions to complex problems. Over the years, scientists have spent huge resources on research and developmental works around quantum theory. These efforts began way back in the early 1900s when Max Planck submitted his study on the subject to the German Physical Society. At the time, Planck was eager to find out why the radiation from a glowing body changes color as its temperature rises. To answer his questions, Planck set out on an adventure of experiments, and eventually, he found that if he could quantify the individual units of energy in the same way that we do to matter, then he could find the perfect answer to his question. Ultimately, he assumed existence of the individual units of matter would become the first significant piece of quantum theory. But Planck was not done just yet. To further strengthen his argument, the German theoretical physicists derived a mathematical equation that included a definite figure to represent the so-called assumed individual units of energy. This figure is what we know today as quanta. Planck's discovery was revolutionary, and his efforts were duly rewarded as he won the Nobel Prize Award in Physics in the year 1918. But of course, quantum theory was in no way complete. The main idea about the concept was already established, but it needed to be refined. So the great Albert Einstein dug into the theory to offer his own opinion. After some extensive study, Einstein found that both the energy and the radiation itself can be quantized in the same way. Furthermore, Louis de Broglie, a renowned French physicist, proposed in 1924 that matter and energy are basically the same in terms of makeup and behavior. His submission on the subject became known as the principle of wave-particle duality. Soon after, a German theoretical physicist named Werner Heisenberg invented the uncertainty principle, which states that it is impossible to precisely and simultaneously calculate the measurement of two complementary values, like the position and momentum of subatomic particles. As the years rolled by, scientists came up with the Copenhagen interpretation and the many worlds theory, which are two major interpretations of the implications of quantum theory as it relates to reality. Proposed by Niels Bohr, the Copenhagen interpretation states that a particle is whatever it is measured to be. But critically, the existence of the particle or its properties cannot be proven until the particle is measured. In other words, Bohr was literally saying that objective reality does not exist. And coincidentally, his position bears close resemblance with the paradox of quantum superstition, which posits that any object can exist in all possible states at the same time, until they're measured or checked upon. They further explain this concept. Scientists came up with an experiment called Schrödinger's cat. Devised by Austrian physicist Erwin Schrödinger, states that if you lock a hypothetical cat and throw in a vial cyanide, there's no way to tell if the cat is dead or alive because we really can't tell if the cyanide capsule is open or not. In this case, the cat is assumed to be in a state of quantum superstition, where it is both dead and alive. However, this mystery is solved once we break the box open and determine the true state of the cat. If you think the Copenhagen interpretation is confusing, wait till you hear the mystery behind the many worlds theory. Basically, the many worlds theory holds that every time we observe an object in a particular state or outcome, there are other parallel universes in which different quantum outcomes become a reality. And somehow there's a mechanism of interaction between these universes that ensures that these different states and outcomes are accessible and can coexist side by side. Over time, scientists like Stephen Hawking and Richard Feynman have explored the many worlds theory and how it relates to quantum theory, but admittedly, the most significant progress in our quest to study the quantum world has been achieved in recent times. For instance, in June 2010, the journal Nature Photonics revealed how a group of scientists teleported photons over a distance of approximately 10 miles using quantum entanglement. Before then, scientists had actually performed a similar experiment with photons, separated by a distance of hundreds of yards. However, the experiment by the Chinese scientists was much more superior because it traveled over a longer distance while maintaining a data integrity of 89%. Fast forward to 2019, Google struck an iconic partnership with NASA Oak Ridge National Laboratory to achieve a milestone known as quantum supremacy. And thanks to this initiative, the three organizations designed a super advanced quantum computer. Powered by Google's Sycamore quantum processor, this newly invented computer allowed them to compute in seconds, an enormous amount of data that even the world's largest and most sophisticated supercomputers would require years to process. In the history of mankind, this was perhaps the closest interaction we've seen between artificial intelligence and quantum computing, and of course, it created a lot of excitement within the science world. For NASA scientists, the hope was that someday they would be able to use this technology to support space missions with a view to increase efficiency. The prospect of using quantum simulations to support the design of light and robust materials for modern spacecraft was also discussed. By December 2020, NASA announced they had achieved long-distance quantum teleportation over 27 miles. More interestingly, scientists revealed that the transferred qubits travel faster than the speed of light. Aside from this incredible transfer speed they offer, the quantum communication systems are considered to be more secure than regular networks because they utilize photons rather than computer code, which is susceptible to hacking. Such is the power of quantum computing. Having watched from the sidelines as Google and NASA demonstrated their technical know-how in the field of quantum computing, companies like IBM and Microsoft are now actively working to build quantum systems of their own. Major efforts like this could lead to a scientific revolution that would change our lives forever, and scientists seem to agree. According to Michio Kaku, a well-renowned physicist, the evolution of quantum computing in the coming years will upset the norm and introduce us to an era of unprecedented scientific and societal change. Imagine a world where computers would no longer need transistors because their ability to manipulate numbers will be powered by subatomic particles, and the average processing time will be trillions of times faster than it currently is. In addition, quantum computing will allow us to convert byproducts like carbon dioxide into useful fuel in a recycling process that would generate cheap, efficient, and unlimited fuel for rockets and other space and land vehicles. Quantum computing will provide effective treatment for diseases like cancer, Alzheimer, and Parkinson's diseases. That would be incredible. In fact, Michio Kaku predicts that at their peak, quantum computers will be able to unravel the secrets of life and the secrets of matter because the language of nature itself is hinged on the principle of quantum. But, as always with every developing technology, pioneers of this interesting interaction between AI and quantum computing are faced with some pressing issues, ranging from ethics to human job loss and the possibility of the human race being wiped out completely from the surface of the Earth by this same technology. For instance, Goldman Sachs estimates that around 300 million people are at risk of losing their jobs as a result of the impending AI invasion and other automation technologies. One can only imagine how many more jobs will be lost if or when we eventually succeed in integrating AI with quantum computing.